This video will cover in Class 3, which is day 1 of Standard 1. We're going to be introducing two topics today called segment addition and then also the idea of a midpoint. Before we do that though, we're going to spend a quick few minutes here reviewing what you should know from our vocabulary and notation unit. So your goal is to look at these four figures, A, B, C, D, and identify what you see. For each of these images, there are two things to do. Give a correct name for the figure, so that's using specifics like the letters that are involved on those figures, and then also match the figure with the correct vocabulary word from this vocabulary word bank off to the side. It would be a good idea to go ahead and pause this video so that you can give those four problems your best shot, and then when you resume the video, you'll see answers so that you can check your work. All right, welcome back. We are looking in this first diagram at a geometric figure that continues forever in both directions thanks to those arrows. So you should have selected the vocabulary word of line. If you look at figure B, it does not continue in both directions, so that would be a line segment. Whereas figure C doesn't have a piece of a line or a line segment at all, it's just this dot that represents a point in space, a location in space. We call that a point. And then finally, for figure D, we've got a geometric figure that starts at a particular location, point C here, and then continues on forever in only one direction through point D. That's what we call a ray. If we come back through and we give these figures names, to name lines, line segments, and rays, we always need two letters. The order of the letters doesn't matter for lines or line segments. You just need 2 points that are on the line or the line segment, and then you need the correct notation above those two letters. So for a line, it can be any 2 points on the line, and then the line symbol above those two letters. For a line segment, it can't be any 2 points. It has to be the end points. Those are the only ones available in this diagram, but if there was a third point available like C, we would ignore that one, and we would just focus on using the A and the B to show where that line segment starts and stops. And then it would get a line segment bar, but no arrows above those letters. You could also talk about B and A in that order. The line segment starts at B and ends at A. For points, you can include the word point with the capital letter, or you can just use the capital letter by itself. And then for a ray, the order of the letters is important. We must talk about where that ray begins first, so point C, and then a point that it passes through. That would be D. And then the ray symbol only has an arrow on the right side to show that it continues on forever through D. If this ray had another point on it, let's say point E, we could also name it ray CE. It starts at C, that's the end point, and then it passes through E and continues on forever in that direction. Okay, hopefully that review from vocabulary and notation over the past few days went well for you. So now we're headed on to the new material for Standard 1. So the first idea we're going to look at is called segment addition. And we're going to test your instincts to see if your instincts are good. So first things first, we've got two letters here, H and J. Normally we would expect those two letters to have some kind of a symbol above them, maybe a line symbol or a segment symbol or a ray symbol. If we take a peek at the diagram, between H and J would be a segment, but when that segment bar disappears, it symbolizes something different. This symbolizes the length of segment HJ. So it's a shorthand way, if we just put the two letters without a bar above it, to describe the length of that segment. So what they're asking us to think about is how far, or what the distance is, between point H and point J along that segment. What do you think it is? If it's 7 centimeters from point H to point K, and then 15 more centimeters from point K to point J. Hopefully your brain is telling you maybe to add those two distances together to get the total length between those 2 points. So 7 centimeters plus 15 centimeters would be 22 centimeters total. And that's the idea of segment addition. Part B is similar, but if we look at the information we're being given, not all of it is actually on the diagram. They're telling us here the length of HJ actually is 33 inches. I don't see a 33 down here anywhere. So it would be a good idea anytime you have information that's not on the picture to label it for yourself. So all the way from H to J is 33 inches. And this time the goal is to figure out the length of segment KJ. That's where these question marks are filled in here. What do you think we should do this time? If your thoughts were to take that total and to remove or to get rid of HK with subtraction to fill in what that leftover piece would be equal to, that was a good idea. You should end up with KJ being equal to 16 inches if you do that subtraction correctly. And then last but not least, we've got a different clue in part C here. They're telling us that K is in the middle of segment HJ. So the middle doesn't just mean anywhere randomly along the segment like we have in these two other examples. Could be closer to H, could be closer to K. The middle means the middle. So it means that from K to H and from K to J have to be identical. So when they ask us up here for the length of segment KJ, we can use that abbreviation to talk about the length of KJ. Just don't include the bar above those letters. That's going to be exactly the same, since this is the middle point, as the distance between H and K. So 5 centimeters. Okay, we're going to formalize some vocabulary here. The idea of segment addition is something called a postulate. In geometry, the idea of a postulate is something that we can't necessarily prove is true, but it makes sense. And so we use it as an idea to help us solve problems. Whereas a definition, which is what we're going to learn about when it comes to midpoints, is an official explanation of what that word means. So when we look at segment addition postulate, this is going to be a reason that we can give for work that we're going to do to solve for different segment lengths. Same thing with definition of midpoint. That's another reason that we can use to explain our work. The segment addition postulate talks about how we can take parts of a segment, and those parts of a segment can be added together. And when that happens, so think about this, HK added together with KJ, what that's going to do is it's going to equal to the length of a larger whole segment. So if we're looking back at example A, we can write out what's called a general equation by naming those parts that were added together using the letters in the diagram. So we have the length of HK, the length of segment HK. We added that to the length of segment KJ, and then that was equal to this entire length of segment HJ. So a general equation doesn't typically have the specific measurements. It just has the names for the lengths that are involved. Then to solve, we can substitute in the values that they give us. So HK up here is equal to 7 centimeters. KJ in the diagram was equal to 15 centimeters, and we did not know HJ at the beginning, so there wouldn't be anything to substitute there. 7 plus 15 then is equal to 22, and that gives us our answer for HJ. So in geometry, it's not just about getting the answer, but it's also about justifying your answer with both work and sometimes these general equations, and also sometimes with reasons. The reason related to this idea would have been segment addition postulate. Part B is very similar. We can use the same general equation when we're looking at part B up here. We still have HK added to the length of segment kj, and that's equal to the length of the entire segment, hj. But this time when we substitute our values in, hk is given to us as 17. We don't know kj, so we can leave that. But hj, that whole distance, was given to us. Now, when we did this problem the first time, I did it with subtraction, 33 minus 17. That's exactly what this algebra equation would result in. Subtract 17 from both sides to isolate that kj and land on your answer of 16. All right, continuing on, we're looking at definition of midpoint next. So a midpoint is going to be a point on a line segment. Sometimes we just call those segments, by the way, so if you leave out the word line, it's okay. That point, though, specifically divides the segment into two equal parts. So it's not just a random location, it's actually the halfway point of the line segment. And believe it or not, we use that idea up here when we were looking at example C. When K was in the middle of HJ, that really tells us that K is one of these midpoints. And so what we were able to do is we were able to say that HK was equal to the same as KJ. So our general equation wouldn't have addition in it this time, it would just be equals. We substitute in 5 for HK because that's what it's equal to, and then that tells us what KJ is equal to. KJ was equal to 5 centimeters, since those were the units used. Now, this equation can show up in a couple of different ways, using the idea of the halfway point as well, but we'll see that on day 2 when we do more work with segment addition postulate and midpoints.